Welcome to Space Graders. We are thrilled to have you join us on this journey of discovery and inspiration. Today, we delve into the fascinating world of Pluto, a celestial body that continues to intrigue scientists and space enthusiasts alike. Pluto, once considered the ninth planet of the solar system, has long intrigued scientists and astronomers with its unique characteristics and distant location. It is classified today as a dwarf planet and resides in the Kuiper Belt, a region filled with icy bodies beyond Neptune. Pluto was first discovered in 1930 by Clyde Tombaugh and remained classified as a planet until 2006, when the International Astronomical Union redefined what constitutes a planet and reclassified Pluto accordingly. Despite this change in classification, Pluto continues to be a subject of fascination and scientific study. The origin of Pluto dates back to the formation of the solar system around 4.6 billion years ago. It is believed to have emerged from the protoplanetary disk of gas and dust that eventually formed planets, moons, and other celestial objects. Some theories suggest that Pluto might have initially been a moon of Neptune before being ejected into its current orbit. Others propose that Pluto is one of many planetary embryos that never accumulated enough mass to clear its orbit, a necessary criterion for planetary classification. In terms of size and dimensions, Pluto is relatively small compared to the planets in the solar system. Its diameter measures approximately 2,377 kilometers, 1,477 miles, making it about two-thirds the size of Earth's moon. Pluto's mass is significantly less than that of Mercury, the smallest recognized planet, and its volume is only about 0.6% that of Earth's. Pluto's orbit is highly elliptical, taking it at times closer to the Sun than Neptune, though this occurs only for a short period during its 248-year-long revolution around the Sun. Pluto is located in the Kuiper Belt, an expansive region filled with icy bodies, dwarf planets, and remnants from the early solar system. Its average distance from the Sun is approximately 5.9 billion kilometers, 3.67 billion miles, equivalent to 39.5 astronomical units, AU. This distance varies due to Pluto's elliptical orbit, bringing it as close as 4.4 billion kilometers, 2.7 billion miles, at perihelion and as far as 7.4 billion kilometers, 4.6 billion miles, at aphelion. The distance from Earth to Pluto fluctuates significantly depending on their respective positions in their orbits. At its closest, Pluto is about 4.28 billion kilometers, 2.66 billion miles from Earth, while at its farthest, it extends to around 7.5 billion kilometers, 4.67 billion miles. Pluto has a thin and dynamic atmosphere composed primarily of nitrogen, with traces of methane and carbon monoxide. This fragile atmosphere expands when Pluto is closer to the Sun and collapses when it moves farther away. The presence of methane helps Pluto retain some heat, but its surface remains extremely cold, with temperatures ranging from minus 375 degrees Fahrenheit to minus 400 degrees Fahrenheit, minus 225 degrees Celsius to minus 240 degrees Celsius. The thin nature of its atmosphere prevents any significant greenhouse effect, making it one of the coldest known bodies in the solar system. The dwarf planet has 5 known moons, the largest of which is Charon. Charon was discovered in 1978 and is unusually large compared to Pluto, with a diameter of 1,212 kilometers, 752 miles, making it over half the size of Pluto itself. Due to its significant size relative to Pluto, the two bodies are often considered a binary system as they orbit a common center of mass that lies outside Pluto. The other 4 moons, Styx, Nix, Kerberos, and Hydra, are much smaller and have irregular chaotic orbits due to the gravitational interactions between Pluto and Charon. Pluto's surface is diverse, composed mainly of rock and ice, and displays a range of geological features. One of its most well-known regions is Sputnik Planitia, a vast, smooth, ice-covered basin composed primarily of frozen nitrogen. This reflective heart-shaped feature became famous after images from the New Horizons mission captured it in 2015. Other surface features include towering mountains made of water ice, some rising to heights of 3,500 meters, 11,000 feet, suggesting that Pluto may have experienced tectonic activity in the past. Evidence of cryovolcanism, or ice volcanoes, has also been observed, indicating that Pluto may still experience geological changes despite its distance from the Sun. So far, only one spacecraft has visited Pluto. NASA's New Horizons probe, launched in 2006, made a historic flyby of Pluto on July 14, 2015. This mission provided the first close-up images and data about Pluto's atmosphere, surface composition, and moons. The flyby transformed our understanding of Pluto, revealing a world with complex geology, an active atmosphere, and surprising levels of surface activity. New Horizons continued its journey beyond Pluto into the Kuiper Belt, where it has studied other distant objects such as Arrokoth. Despite the success of this mission, no further spacecraft have been sent to Pluto, though discussions about future missions continue. Pluto was initially classified as the 9th planet of the solar system, but its status changed in 2006 when the International Astronomical Union redefined the criteria for planetary classification. To be considered a planet, an object must orbit the Sun, have sufficient mass to maintain a nearly round shape, and clear its orbit of other debris. While Pluto meets the first two criteria, it fails the third, as it shares its orbital neighbourhood with numerous other Kuiper Belt objects. This led to its reclassification as a dwarf planet, sparking debates among astronomers and the public alike. Although Pluto does not provide direct benefits to Earth in terms of resources or colonization potential, studying it helps scientists understand the broader workings of the solar system. Insights gained from Pluto and other Kuiper Belt objects contribute to knowledge about planetary formation, migration patterns, and the chemical evolution of celestial bodies. Understanding Pluto also aids in the study of exoplanets, many of which share similar characteristics. The technology required to reach Pluto remains a significant challenge due to its vast distance. New Horizons took nearly a decade to arrive at Pluto, travelling at speeds exceeding 58,000 kilometres per h, 36,000 miles per hour. Future missions could utilise advanced propulsion systems such as nuclear propulsion, ion drives, or solar sails to reduce travel time. Given the extreme cold and lack of a solid landing surface in some areas, any future lander would require advanced insulation, powered descent systems, and a nuclear-based power supply, as solar panels would be ineffective at such a great distance from the Sun. A robotic lander mission to Pluto has been proposed as the next step for further exploration. A lander would enable direct surface analysis, studying the chemical composition of Pluto's ice, searching for signs of geological activity, and possibly investigating whether a subsurface ocean exists. Such a mission would also help determine the nature of Pluto's thin atmosphere and how it changes over time. However, designing a lander that can withstand Pluto's harsh environment and operate effectively at such a vast distance poses numerous engineering challenges. Power supply limitations, communication delays, and the difficulty of selecting a safe landing site all add to the complexity of sending a lander to Pluto. Currently, no human missions to Pluto are planned, and it is unlikely that humans will visit in the near future. The logistical challenges of sending astronauts to such an extreme location, combined with the long travel time and lack of an immediate scientific or economic incentive, make human exploration of Pluto impractical at this stage. What do you think about Pluto? Do you believe we should continue exploring it? What benefits do you think we can achieve from further exploration? Let us know your thoughts in the comments. Don't forget to give this video a thumbs up, subscribe to Space Graders, and stay tuned for more exciting space discoveries.